All right, family, let's talk about something that nobody's talking about, but everybody should be paying attention to: uranium. You heard me right. The key ingredient behind nuclear power, the most efficient and reliable energy source on the planet. But if that's the case, why is it so controversial, misunderstood, and underutilized? Well, strap in, because today we're unlocking the bag on uranium, its history, its economics, and the massive opportunity sitting right in front of us. Chapter 1: The history of uranium, from discovery to domination. Uranium wasn't always the energy superhero, or villain, depending on who you ask, that we know today. Let's go back to 1789, when Martin Klaproth first discovered it. But it wasn't until the 20th century that we realized its true potential. And with that, its controversy began. The atomic age begins. The Manhattan Project in World War II led to the first nuclear bombs, forever linking uranium with destruction. But at the same time, scientists discovered its potential for peaceful energy production. Nuclear power boom. By the 1950s and 60s, nuclear energy was seen as the future of electricity. The US and Europe were building power plants like crazy, and uranium demand skyrocketed. When it comes to power generation, nuclear energy is the undisputed king of efficiency. One nuclear power plant can generate enough electricity to power an entire city, and not just a small one. For example, a single large-scale nuclear reactor can supply around 1 gigawatt of power, which is enough to power 700,000 homes. Compare that to solar or wind, which require massive land use and fluctuating conditions to produce a fraction of that energy. Nuclear's base load capacity means it runs 24/7, unaffected by weather conditions, unlike solar panels that go dark at night or wind farms that stop when the breeze dies down. Nuclear power plants also have a much higher energy density than fossil fuels. One uranium fuel pellet, about the size of a fingertip, holds the same amount of energy as a ton of coal or 17,000 cubic feet of natural gas. This means nuclear can generate enormous amounts of energy with minimal fuel, making it the most efficient energy source available today. And if you know anything about what happened to some nuclear power plants in the past, I already know you're thinking, so, what about what happened at 3 Mile Island, Chernobyl, and Fukushima? Public opinion turned against nuclear energy after these disasters, despite technological advancements that have since made nuclear safer than ever. The oil industry capitalized on this fear, and that brings us to our next chapter. Chapter 2: The Energy Wars, Oil versus Nuclear. If nuclear is so efficient, why did it get left behind? Well, follow the money. Big Oil wasn't about to let nuclear take its spot as the king of energy. Uranium has a controversial history, largely because its association with nuclear weapons has overshadowed its incredible potential as a clean energy source. The Manhattan Project and Cold War arms race ingrained fear into the public's perception of uranium, and the devastating consequences of nuclear bombings left a lasting impact. However, outside of weaponization, uranium has been used for peaceful purposes for over 70 years to generate electricity. In the 1970s and 80s, oil companies, threatened by nuclear's potential, ran misinformation campaigns to stoke public fear about nuclear power. The fossil fuel empire. Oil and coal were already deeply embedded in global economies. Companies like Exxon, Chevron, and BP had and still have massive lobbying power to protect their interests. Smear campaigns that the fossil fuel industry funded, such as anti-nuclear narratives, highlighted accidents like the high-profile disasters of Chernobyl in 1986 and Fukushima in 2011, further cemented nuclear's reputation as dangerous. Even though modern reactor designs are significantly safer, and the actual death toll from nuclear accidents is minuscule compared to fossil fuels, their government influence had politicians backed by oil money and helped stifle nuclear expansion through excessive regulations, making it more expensive and less competitive. Chapter 3: Terawatt hours and the power of uranium. To understand uranium's potential, let's talk terawatt hours, a measure of large-scale electricity production. What is a terawatt hour? It's a unit of energy representing 1 trillion watt-hours, or enough to power 90,000 US homes for an entire year. What is a kilowatt hour? This is what's on your electricity bill. 1 kilowatt hour equals running a 1,000 watt appliance for 1 hour. A household in the US typically uses about 10,000 kilowatt hours per year. Now, let's compare nuclear to other energy sources using terawatt hours. Nuclear power. provides around 2,500 terawatt hours per year worldwide, supplying nearly 10% of global electricity, despite being underutilized. Coal, the largest energy source, but responsible for thousands of deaths per year due to air pollution. Solar and wind, clean but intermittent, requiring backup storage and a vast amount of land use. Chapter 4, the safest energy source. Let's talk numbers. Let's put fears about nuclear energy into perspective. We often hear about nuclear disasters, but what about the everyday toll of fossil fuels? Death per terawatt hour. Comparison. Coal has approximately 24 deaths per terawatt hour due to pollution and mining accidents. Oil, approximately 18 deaths per terawatt hour from extraction hazards, refining, and pollution. Natural gas, approximately 3 deaths per terawatt hour. And nuclear, only 0.03 deaths per terawatt hour. Wait, what? Yes, nuclear is literally one of the safest energy sources per unit of electricity produced. Even hydroelectric power, despite its clean reputation, has had more deaths from dam failures than nuclear power plants have ever caused. Now, let's talk about carbon emissions. Coal with 820 gigagrams of CO2 per kilowatt hour. Oil, 650 grams of CO2 per kilowatt hour. Natural gas, 450 gigagrams of CO2 per kilowatt hour. And nuclear with only 4 grams of CO2 per kilowatt hour. This makes it the lowest of any major energy source. So despite all the fear, nuclear has almost zero emissions and the best safety record. Chapter 5, the massive energy shortfall coming. Let's be real for a second. The world is walking straight into an energy crisis and most people have no idea. The demand for power is skyrocketing and the current energy infrastructure just can't keep up. If we don't find a real solution, we're looking at blackouts, energy rationing, and skyrocketing electricity prices. The global power demand is exploding. Think about how much energy we use today compared to 50 years ago. Now, imagine doubling that. That's where we're heading. The International Energy Agency, IEA, projects global electricity demand will increase by over 50% by 2040, and that's a conservative estimate. Why? A few key reasons. Developing nations are plugging in. Countries that were once labeled third world are rapidly modernizing. Nations in Africa, South Asia, and Latin America are building out power grids so their populations can finally enjoy the kind of life that developed nations have had for decades. This means billions of people are going from barely using electricity to demanding air conditioning, refrigerators, and digital infrastructure. AI and data centers need massive power. Here's something nobody is talking about. AI and data centers are eating the world's electricity. Training. AI models like ChatGPT or running massive cloud computing operations takes an insane amount of power. A single Google data center consumes as much electricity as 250,000 homes. The AI industry alone is projected to consume as much energy as an entire country the size of Argentina by 2030. Bitcoin mining, same story, massive energy draw. The EV boom is just getting started. Governments around the world are pushing for electric vehicles, EVs, banning new gas car sales by 2035 or sooner. But here's the problem, the power grid is not ready. A Tesla supercharger station can pull as much energy as a skyscraper. If 50% of all cars go electric, we'll need to double our electricity generation. The US grid barely handled the Texas winter storm. How will it handle 100 million EVs charging overnight? So, what's the plan? Right now, governments are hoping wind and solar will save the day, but the numbers just don't add up. Why wind and solar can't handle it. Wind and solar are great supplements, but they can't provide the constant, reliable energy we need. Solar only works when the sun shines, and even in sunny areas, cloud cover can kill production. Wind is unpredictable. A calm week can send power production plummeting. Energy storage isn't there yet. We don't have the battery tech to store massive amounts of solar and wind power for days or weeks when conditions aren't right. Germany tried to go all in on renewables with its Energiewende policy. The result? Energy prices soared to some of the highest in the world. They had to restart coal plants because wind and solar weren't cutting it. Carbon emissions actually went up. So what's the only real solution? Nuclear is the only answer. Nuclear provides a massive, stable energy output. A single nuclear power plant can power over 1 million homes 24/7. It's cleaner than every other source. Zero carbon emissions, no air pollution. It's safer than you think. We already covered how it has fewer deaths per terawatt hour than coal, oil, or even hydropower. Countries that embrace nuclear have the cheapest electricity. Look at France. They get 70% of their power from nuclear and pay way less for electricity than Germany, which shut down its reactors. The clock is ticking. Here's the harsh truth. If we don't start building more nuclear plants now, we will not have enough power for the future. It takes 5 to 10 years to build a new nuclear plant, so if we wait until the blackouts start happening, it's already too late. Governments are starting to wake up. China, India, and even the US are investing billions in nuclear power. But is it enough? The demand keeps rising, and the supply isn't keeping up. The world needs way more uranium to fuel this next wave of nuclear energy. And right now, there isn't enough uranium production to meet demand, which means prices could skyrocket. The bottom line, the energy shortfall isn't coming. It's already here. And nuclear is the only energy source that can bridge the gap. If you're thinking about where the world is heading, uranium might just be the most valuable resource of the next decade. Chapter 6. The supply and demand opportunity in uranium. Now let's talk investing. As I mentioned earlier, uranium prices have been skyrocketing due to supply shortages and growing demand. Why the supply is tightening? Decades of underinvestment. After the anti-nuclear push, uranium mining slowed dramatically. Now, supply is struggling to catch up. Mine closures and geopolitical risks. Some of the world's biggest uranium producers, like Kazakhstan and Canada, have faced production cuts and instability. Rising global demand. Countries like China and India are aggressively expanding their nuclear power plants. Even the US is rethinking nuclear. The bottom line, the world is waking up to the reality that we need nuclear energy, and the uranium supply is struggling to keep up. This presents a massive investment opportunity. Conclusion, it's time to reconsider uranium. So, why haven't we been talking about uranium? Because the powers that be didn't want us to. But the truth is clear. Nuclear energy is the safest, most efficient, and cleanest source of power. The world is running out of energy, and nuclear is the only solution that can meet demand. Uranium is massively undervalued, and the investment opportunity is enormous. If history has taught us anything, it's that change is inevitable. The question is, are you paying attention? This is Unlocking the Bag, where we don't just talk money, we talk real money. See you in the next one.